Hi, I'm Kevin Jones from Ectobox, and I'd like to talk with you about the types of IoT solutions that are out there. And we'll talk about manufacturing, three levels of in manufacturing, and also put it in the context of a three-layered cake. So the types of IoT solutions that are out there, our take on them, there are some that are better than others. Uh, let's start off with the homemade solutions. Arduino, Raspberry Pi, people will try to use those to attach sensors, process a little bit of data on the Linux operating systems that are on them, or Windows, and then push that data out using Node-RED over to a web cloud-based solution. And they work well enough when they're working, but they are not really heavily reliable in heavy industry. Manufacturing can be dirty, can also be very clean. I've seen many clean plants, but it can be very dirty, very hot, and there's also a lot of data, and that data is incredibly valuable. And also some of these systems are not as secure as they really could or should be. And so the question to ask yourself is, do you really want your manufacturing plant to rely on data that's coming out of an Arduino or a Raspberry Pi system, which could go down at any moment? And you're going to need that original individual programmer that might be your next door neighbor's nephew in high school that created it. I know people who create solutions with these products, and they're really, really smart people. However, on the whole, those kinds of products probably don't make sense for heavy industry. Siloed IoT products. There are two types. Those two types are one, the types created by manufacturers of equipment, CNC machine manufacturers and others will sometimes come out with IoT products that will pull data directly from those machines. And it works really well to monitor the status of those machines, see trends of data, and get some idea of what's going to happen in the future. Maybe get a couple alerts and notifications. However, they don't have the capability to add additional business logic to them to get them into the future-focused, larger situations where you want to communicate data between the layers of a manufacturing company. And also, you can't pull data from other systems to add more context to the data, nor pull data from the cloud. Also, the second type of siloed IoT product are the smaller IoT products that are out there that are not created by manufacturers of equipment, but by startups and other companies. Really smart people, really nice products. They will give you really nice displays of the data. They probably speak one or more of the communication protocols that are typically used in manufacturing, and they have some really nice features. However, there are some drawbacks to those as well, as with anything. One of the drawbacks of those solutions is that they may not have the capability to be customized too much, especially within the realm of the business logic you might want to code or program into the system to then be able to communicate data with other systems. They may or may not be able to communicate with outside systems using APIs and whatnot. Pulling data from the cloud, from ERP, from CRM systems, CMMS systems, pushing data out to those other systems is incredibly valuable to add more context to the data to make this data valuable, because the data that we're working with in IoT is ultimately the gold that we're all mining for. So those limitations make the siloed IoT solutions, limited, let's say, and that's why I've put them on the left side of this chart for the longevity. Business intelligence solutions. They show data really well, analyze data really well, and pull data from multiple systems, but they don't speak manufacturing ease. They don't speak the data communication protocols that are typical in manufacturing. And data can only be pulled from usually relational databases and also some NoSQL databases, but I haven't seen too many that really understand time series or historians as well. They also lack the capability for additional business logic for full integrations, etc. SCADA systems, supervisory control and data acquisition systems, are very good for manufacturing at the plant floor level. However, they're not really great for pulling data from other systems and then pushing that data out. Sometimes it's a result of the technology they've been built on is pretty old. They've been around for a long time and do a great job at the plant floor level, but they have limited capabilities beyond that. Some other newer products that are coming out that we know of and that we like that can perform the functions of SCADA. However, then it becomes a question of what are you going to use the system as a SCADA product or as an IoT product to pull data from everything and wrap and extend all of the data at the company to really make it valuable. Then the last that I'll talk about here is what I call the smart manufacturing and ISA 95 products. These products typically start off as a siloed IoT project, or I should say maybe a simple IoT project. Start by pulling data from a certain set of machines, a limited number of machines, solve a particular business problem on those machines, and then let's start to move forward from there. But ultimately, as a company, that companies will want to become data-driven. They will want to be able to share the right data with the right people at the right time. And to do that, you need to share data between the layers of the organization. So this is where the three-layer cake comes into play. You have the business unit at the top where the planning, execution, inventory, strategy, C-suite, VPs, they all sit up here. Then there's the plant floor with the plant manager, operators, supervisors, etc., working in the plant. And they each need data from the other. But typically what we've found is that that middle layer of the three-layer cake is filled with paper and Excel files. It's great that operators are entering data on pieces of paper, on log sheets for production, for quality, for downtime, but that data takes a long time to get up to the top. And very often, well, sometimes at least, it's inaccurate, and very often it takes a long time to get there. So the business unit then wants to ask questions of their operators, of the plant manager. What happened 2 weeks ago, a week ago, when this, on this piece of paper happened? I don't know. My kids had several birthday parties and a couple of beers with friends over the weekend, and lots of work since then. We've been really busy trying to get orders out, and I just have no idea whatsoever. So the idea at that point is to use the principles from the ISA 95 standard. ISA, the International Society for Automation, is an organization created to create standards, principles, practices around automation and around manufacturing and heavy industry, and how to deal with a lot of different situations in there, and create good standards to create good, solid organizations, good, solid, reliable organizations that can grow. And one of the standards, the ISA 95 standard, was created to organize the ideas within manufacturing and how all of it works and comes together. And one of the ideas that ISA 95 really deals with is how to move the data between one level and the other. There are architectures and designs within ISA 95 standard that allow you to look at a manufacturing company and to organize it into functions, attributes, workflows, etc., and then create an architecture to be able to communicate data reliably from top to bottom and bottom to top. Very often what companies will do is to say, hey, I have this little IoT solution. I want to send some data to an ERP system. Okay, that's fine. Send the data. API call, send the data to a database, whatever the process might be. But that ends up being a point-to-point solution. And then let's send the data to another situation. And then let's send the data to yet another solution as well. And so then at that point, you get a lot of this. You get a lot of point-to-point solutions that don't really work very well together or are difficult to maintain and not very well organized and very expensive to try to modify in the future. Instead, what we should do is to focus on this middle layer and use principles and ideas from ISA 95, including the MOM principles, manufacturing operations model, to organize the data so that you can get clean passing of data from one system to another, from one level to another. Once you do that, then the right people will have the right data at the right time, and the company can become much more flexible, much more efficient, reduce costs, increase profits and margins and revenue, and compete and grow in their market. So the idea again is to start off with the simple IoT solutions, but using a platform that has an open architecture that is easily integratable, has the business logic inside it to be able to create these kinds of integrations and pass data back and forth, and to share the data, visualizations, and also have the capability to process and analyze data in a really good, strong way. And at that point, then you will be able to create a really good, solid, efficient, productive, flexible, competitive company. And so think about when you're creating these simple IoT solutions, think about the future. Solve a couple problems here, business problems. Let's not solve engineering problems. Let's solve business problems here using technology, and then start to plan for the future so that you can have a really good, solid 3-layer cake. Carrot cake with cream cheese icing.